Hi, welcome to Teardown Tuesday. You know I love vintage stuff here on the EEVblog, so I've got another vintage teardown. Bit of consumer history here. This is Sony's first really usable consumer camera. Not quite, actually. The first one was the DSC-F1 model back in 1996, but that didn't have any removable media in it. This was Sony's first camera that actually had removable media. You could take it out with your images on it and stick it in your camera. How novel! And this is the MVC-FD7. There was also the FD5 as well. The only difference is this was the bigger model with the ×10 optical zoom lens on it. Whoa, that was huge for the day. And we're talking 17 years old here, 1997 vintage, and pretty groundbreaking product back then. And what did you get for your money, for your huge amount of money back then? I think it was like $1,400 or something like that, or well over $1,000. I don't know what that is in today's money, but it doesn't seem that long ago, 17 years. But you've got to remember the technology back then. I mean, look at this thing, right? I'll show you in comparison with a modern camera in a minute how big and chunky this thing truly is. But what did you get? Is it, 5 megapixels? 2? 1? A half? No. Try 0.3 megapixels, 640 by 480, and I believe it even had an interpolated sensor in it, so that the sensor was actually less than that. So go figure. But that's what you got back then. But the most amazing thing about this is, check it out. Watch this. What did it store it on? Compact flash card. Hey, that was designed in about 1994, so it could have. But no, you've got to remember, back then there probably weren't any compact flash card readers for PCs. So although the compact flash was around, bit harder. So what did it use? SD card? No, they didn't come around until like 2000 or something like that. Sony memory stick? Nope, that was a year later. What did they store it on? Ta-da! Crikey, look at that. 3.5-inch floppy. But this was incredibly convenient back then because people were still using 3.5-inch floppies. This was groundbreaking that you could just store your images on a 3.5-inch floppy and whack them straight in your PC and use them. You didn't have to hook up a cord, have special software to transfer it and all that sort of stuff. Just saved it as a JPEG on a floppy. Unbelievable. Now, this was the first camera in Sony's Mavica line, and supposedly Mavica stands for magnetic video camera, and it makes sense. It stored it on magnetic media, the 3.5-inch floppy, and hence the FD in the title, Floppy-Disk. And there was a later upgrade for this where you could actually get a plug-in that allowed it to store it onto Sony memory stick at a later date. But these were incredibly useful cameras. These were highly sought after where I worked, and we had these for documenting all sorts of stuff. That was groundbreaking, to be able to take a photo, snap, and then instantly embed it into your Word document for product documentation and stuff like that. Unbelievably convenient. But geez, what a relic. The advance in consumer technology, even in a couple of years from this. I got my first digital camera in around about 2000, so it was only a couple of years after this, and it was a Kodak 2 megapixel one, and only had a ×3 optical lens, but it was ran on standard AA batteries and saved to compact flash card and all that sort of stuff. So really it was a modern camera. I mean, this thing, it is still a modern camera, but floppy disk, hey, well, you can still buy USB floppy disk adapters, can't you? I don't have one, so I'm not able to test this. It doesn't even have a battery, unfortunately. Now, of course, the main problem with using a floppy disk as the storage medium is that, well, if you remember back then, these things took time to write to them. First of all, they had to spin up to speed, then the head had to physically move into position there and write the data and then spin it down. And so this thing would take about 6 or 7 seconds between shots. So you'd press the button, and I don't know how fast the shutter was on this thing and how instantly it took it when you actually press the button, but you'd have to wait 6 or 7 seconds or longer before you could take another shot, because it didn't have any buffer memory in it, before you could take the next shot to save it to your floppy disk. Oh, goodness. But this was groundbreaking back in the day, because the previous cameras, there were previous digital cameras to this, but they had internal memory not on removable card, limited internal memory. You might be able to store, 10, 20, 30 shots or something like that. But this thing, you could carry around as many 3.5-inch floppies as you wanted, and they were pretty cheap back then, and you could store hundreds or thousands of images. This thing has a stamina of 500 shots, so it claims, or a 1.5 hour battery life. So that was pretty groundbreaking to store more photos and cheaper than a film camera at the time. And that was what made digital cameras successful, is that they were just more convenient and eventually became cheaper and easier than your traditional film cameras, and all that happened in the span of just a couple of years. Really amazing before film cameras were meh, except for really high resolution stuff, which it took a few more years after that for the digital cameras to really come into their own. But the amazing thing about this is, even though it was 640 by 480 VGA quality images, right, the image quality was actually really good, because back then they weren't trying to meet these incredibly low price points for these cameras that they are these days, and trying to design the lenses to meet these big high resolution sensors to match these sensors. Well, this thing only had a 640 by 480 sensor. You could easily put a top quality lens on this thing, and this is what they did. So they actually took really good photos. It's just that the resolution was incredibly limited. So you know what we say here in the EEVblog: don't turn it on, take it apart. And just to give you a feel for how big this thing really is, check out, compared to quite a few years old modern pocketable camera. I mean, just look at the thickness of that, the height of that thing. I mean, it's just absolutely ridiculous. Look at that. Crazy. And if you compare it to a modern a compact digital SLR, this is a Sony Nex 5T camera. I mean, just look at that. Unbelievable. And the performance differences, wow. So although it was a big chunky beast, it actually feels like it's built fairly well, fairly solid. I mean, there's no real proper grip on the thing. Ergonomics, yeah, they've put the shutter button here, but that's about as far, and the zoom here, that's about as convenient as it gets. I mean, they've got the auto manual focus on this side over here, so I guess that's not too bad. You can adjust the focus there, but yeah, ergonomics leaves a little bit to be desired. And it ran on a 7.2 volt lithium ion battery back then. Unfortunately it doesn't have one, but we might be able to power it up later if we can get in there and attach a power supply to the contacts. Yes, there was a tripod mount on the thing, and not a huge amount of manual control on it. It wasn't for your professional. It was basically, you pretty much used it in auto mode, most of the time. Yeah, it did have a flash on the front, but yeah, apparently that was pretty poor, and well, but it did have a pretty good lens on it, that ×10 optical lens. So that was pretty decent for the day, and more than matched the sensor, which is the main thing. So you actually got pretty decent shots out of it. Alright, let's take this sucker apart. Not sure where to start, but I'll just take off every screw possible. And yeah, we expect virtually all surface mount technology in this thing. There'll be multiple boards. There'll be a sensor board in there, probably sensor directly mounted on a board after the lens. It'll have some sensor processing. Maybe there'll be another complete processor board in there. I mean, just look at the thickness of this thing. Sure, the floppy drive, takes up a fair good chunk of that, but it's only sort of that section down in there. So there's still all of this in there. I mean, those optics are going to be pretty deep, but look how much the screen protrudes out the back like that. So the screen driver probably has its own board on it, something like that. So yeah, no doubt some custom Sony chips as well. There'll be no surprises there, I'm sure. It'd be interesting to see what sort of processor it used. There was no, maybe they've got like an image processor. They might have had a JPEG processing chip to do that. I'm not sure if they did that like a custom ASIC to do that, like they do these days. They have these imaging chips. Every manufacturer has their own flavor of and architecture of their imaging chips, which does all the processing crunching. Obviously it didn't have to go very fast because most of the time was taken up by writing to the floppy disk. So maybe one, it starts spinning up the floppy disk at the same time it's actually processing and crunching the image, and by the time it's finished processing and crunching, that could take, even if it took a second or two to process and crunch a 640 by 480 VGA image, then really the floppy drive is up to speed and it's ready to write. So it wouldn't have to be quick. So as an electronics designer for this thing, you'd go, oh great, it's storing a floppy, woohoo, I don't have to try and kill myself to design a thing to get it really, hey, hello, to get it right down, hello, it's starting to pop. She's ready to pop. Oh, yeah, we've got some flat flex joining the boards. Yeah, I can see a main processor board down in there. Oh, it's all a bit tricky. Let me try and prise it all open. And it finally did just crack right open and swings out like that. So we've got our, there's all our flash circuitry on the back. You can tell by the huge cap on there, so that charges up for the flash. Probably a little bit of battery management down in there, or battery protection, but here's the main guts of it. And the first thing you notice, which is really interesting, is that that sensor does not go down to the board down there, as I just guessed. I didn't really put any thought into it, but look, they've got it mirrored right angle. Here's the sensor board. Here's the sensor mounted on this right angle PCB here with the flat flex going down to the main processing board there. And yeah, so they're clearly getting a mirror in there and sending the image through there, and it's reflecting down into the sensor, down into the bottom there. Look at that. That's how they can fit probably the full ×10 zoom in this thing in, well, this compact nature of the camera, so you can see how the advancement in technology has really happened. But back then they probably had to do it right angle like that to get that massive ×10 optical zoom in the thing. Wow. Now I'm actually going to see if I can power this thing up with an external bench supply. You can see there's two terminals down in there, which are the tabs for the battery. I mean, I can't get wires down through there, but I can easily access those and solder two wires on. So I'll just check which one's what, because I don't know the polarity. So let's try and find the ground, and we can just do the exposure on the solder mask there. No, nothing. And let's try the other one. Hey, hello. Yep, there we go. Alright, so that's our negative terminal, that's our positive. Hook it up to the bench supply and see if it still works. Now, I know that this thing uses an info lithium battery, so it's one of those smart batteries with built-in electronics to measure, basically to do Coulomb counting pretty much, I believe. So, to tell you the exact capacity remaining in the battery. And, well, it may not even power up if it doesn't have that real battery. I don't know the Sony info lithium data stream or how to simulate or anything like that, but hey, so it's a bit of a long shot, but I'm going to give it a crack. So got it hooked up to my bench supply here, 7.2 volts, just 1 amp current limit. I don't know how much power it takes, so let's turn it on and see what happens. So let's go on. Whoa, it drew some initial current there. Okay, but it's drawing 1 milliamp at the moment. It's drawing a little, a tiny little amount, as you'd expect. So let's see if we can power this thing on. And yeah, it tried to do something there. Yeah, it tried to switch on. Hey, there it is. It's on. It's on. It works. Look at that. I've got it. No disk. Ha ha. Beauty. Can we take a photo? Let's whack the floppy disk in. And wow. Wow, I'm surprised. I'm surprised. Does it go in that way? No. I always put these bloody discs in, even though it's got a thing to tell you which way to put it in. This is a brand new floppy, I believe. 3M floppy. There we go. It recognised the disc. The disc is there. Let's see if we can take a photo. Let me put this thing back on and let's get something interesting in the shot there. Let's get our Fluke multimeter. Got a bit of glare on that. Can't have that. And let's see if we can take a photo of this thing. Wow, here we go. I'm going to put it on auto. Yeah, it's on auto. So, here we go. Recording. Look at that. Is that recording the shot? I don't think it does video. Clunk. Look, it did it. I think it took a photo. Can we play that back? File access 1 of 1. Yep. Oh, this is terrific. Wow. There we go. It works. It's alive. And curiously, look, it shows the battery half full there. So I'm not sure how good that smart info lithium is, because I got nothing hooked up to that third terminal. Wow. And in case you're wondering what sort of power it takes there we go. 2.5 watts just statically displaying the image. And here we go. I'll go back to camera mode. And there we go. We can see it. There we go. 3 odd watts there. So there you go. My 1 amp current limit, you know, I thought 7 watts would be, you know, plenty for it. And sure enough, there it is. I'm moving the image around at the moment, but that's how much it takes. Now I'll shoot another photo, take another shot. So it's recording to the disk. Here we go. There we go. It's jumping up to 5 watts. That's what happens when you record to floppy. Still writing, and it should drop back down. Yep, there we go. So that was a little bit of a shot in the dark, but it worked, and this camera still works. I mean, look, I can't even see any dead pixels on that display after about 17 years. I'm not sure what the resolution of that is. Geez, what would it be, that, you know, 240? It's not even 320 by 240, I don't think. The resolution of that screen is pretty poor, but geez, that is great. It still works. My floppy disk still works. My original 3M floppy disk. It's brand new, straight out of the packet. How do we jump? Oh, we've got to go up there. That's annoying. I'm using the joystick thing. File access. Yeah, it's pretty annoying to go between images. Let me tell you, it takes forever to file access 2 of 2. There we go. Not exactly easy to replay your photos. Look at that. But hey, this for the day, I'm telling you, this thing was the duck's guts. And as for the zoom on this thing, it actually it had variable speed, so I can move pretty quick. And if I can make it go like slow like that, or if I really push it. So it had velocity sensing on that little thumb switch there, so that's great. This really worked a treat. I'm telling you, this was a pretty good go. Apart from the resolution and just the general dickiness of using it, it was actually it got the job done. It was pretty reasonable. And yes, we have different picture effects here. Check this out. Oh, state of the art. Dedicate a button for it. Pastel, negative. Look at that. That's great. That's great. To be able to do that in camera, sepia, what's that, black and white, that's just, yeah, that's terrific. So you might think the 640 by 480 resolution on this sensor here is just, you know, what use was it? Well, it was perfectly fine for doing shots for your website, for example. Well, you know, the web hadn't been around very long back then, only been around 5 years or something like that. So to be able to put photos on your website was absolutely phenomenal. And of course, someone like a reporter, for example, could be out taking a photo, and hey, they could even get a negative effect or something like that if they wanted to, and then they could rush the floppy back to HQ, and then bang, it'd go straight in that day's newspaper, or that nightly news at night, because 640 by 480, of course, would be perfectly fine for standard definition television back in the day. Not a problem whatsoever. So it'd be great for like just in the field reporting and stuff like that. But yeah, as I said, the technology progressed pretty darn quick. But hey, you know, if you got a year's use out of this thing, a year or two, then hey, it would have been fantastic. There we go. I was able to take the whole lens and sensor assembly out, and you can see there is our mirror. So there's our input, so there's nothing behind there, it's just a mirror, and of course all of the zoom and optics is all happening inside that puppy. And of course we've got some flat flex there going over. I mean, flat flex has been used in cameras since, geez, the Polaroid ones back in the 70s. I think the actual Polaroid, the Instamatic, the first Instamatic camera was, I think, one of the first consumer items, don't quote me, but I think it was, to use flat flex technology for joining things together. It looks like we've got ourselves 3 motors in this sucker. That one down in there. We've got one tucked in here. They're all joined with flat flex, of course. There it is. And, well, there could be another something in there. And so there could be 4, actually. But that one's hidden away. We can't see it. And another one over here. So we probably have a couple of motors for the zoom elements. So there'd be probably multiple elements in there for the ×10 zoom and focus and stuff like that. So yeah, it needs a few motors, but that's a nice little assembly. But look at that. I mean, today's modern ones, they go directly into the sensor chip straight behind here. None of this mirror bullshit to get your ×10 zooms. Alright, everyone's dying to see this staggeringly huge sensor. 640 by 4, wait, it just popped off there. There we go. I have read that it was actually, it's not 640 by 480, it's actually 640 by 240. So anyway, I'll get this under the digital microscope. I've got my new Teardown microscope hooked up, and we'll have a look at that puppy. Alright, let's have a look at this under my Teardown microscope. I've finally got this thing working. I'm capturing it using my AVerMedia HDMI Pro capture card, and I can zoom right in. Well, we're nowhere near it yet. It's rather annoying having that zoom text come up on the display, but here is the sensor, and we'll be able to go pretty much right inside that sucker. And there it is. Gets a little bit noisy as we go in, but because the light is lower in there, of course. But there we go. That is the sensor. So it does look like it's 640 by 480. So I read that it might have been a 640 by 240, and then upscaled up. But so yeah, sorry, it's really quite hard to see through this really deep lens on the thing, and I don't want to take the lens off just to get in there and have a look at the sensor. But that's the full zoom. Yeah, that's full zoom on my Teardown microscope. But there we go. You see the bond wires, gold bond wires going over there. It's a serial output CCD device, of course. And that is a thing of beauty. Look at that. What a Bobby Dazzler. State of the art for the day. Oh, beautiful. I love this microscope. It really is quite nice. It's I'm recording directly from the HDMI output using that HDMI Capture Pro card, and it's got H.264 hardware compression built in. So I'm recording this on an old Core 2 Duo machine, because all that processing is done in the hardware basically, and then it doesn't have to do much. It's just recording to a regular old hard drive. So this ancient machine is capturing full HD from HDMI at 25 frames per second. It's capable of 30. This Teardown microscope gives 60 frames per second output, but the capture card's not that good. It can only do 30 maximum, but I'm capturing this at 25 frames per second to match my regular video camera, which is all at 25. So there you go. Neat little sensor. Alright, let's take a look at the main board here, and pretty much all of the electronics is on here except for the display controller, I believe. So let's have a look. To give you a bit of orientation, this was the power coming in up over here. This is obviously going off to the display over here, and then these were our CCD inputs down here that went off to our camera and the motor drive and stuff like that. So let's start out by having a look at this beast here, and this is a Hitachi, now Renesas of course, SH7034 32-bit micro, 26 MIPS. It's only got like 4K of memory built in. It's working at 20 megahertz. You can see the oscillator there. And over in this corner here, obviously the big inductors and caps here. This is all part of our DC to DC converter, and obviously this is our DC to DC controller here. It's an MB3785A. It's a 4-channel controller. We get our first look at a date code here. There we go, the 44th week 1997. And of course this is our power input here coming from the battery compartment as we saw before. So all that generates all our different rails required inside this thing. Now this part here, I couldn't actually get any data on that. I didn't spend too long, but anyway, that's working at 20 megahertz as well, separate, and it's got part of the real-time clock there as well going into that. But that's obviously some sort of the display controller, because it's right near the display connector here, so that's got to have something to do with the display on this thing. And then if we go over to this one around here, woohoo, this microscope is fun, this goes off to our floppy drive, and sure enough, this NEC part, if you can look straight in there, the 72069 GF, that one is our floppy drive controller, so that's working at 16 megahertz, and that of course offloads all of the work from the processor to drive the floppy drive, and we've got some memory associated with that with these devices around here as well. Now this part in here, what you at first glance you might think it's a memory like these parts here. These are 512k DRAMs there for the main processor, but look, this is an MB9089, and what this sucker is it's an on-screen character generator. So as you saw previously in the video, how all that text was being displayed on the screen wasn't being displayed by the processor. Well, the processor was sending the ASCII characters and the positional data, but this chip is actually an on-screen video display controller with either an RGB or a PAL NTSC YC video output. So it's actually outputting a video signal which then must go to the screen. So the screen is actually a composite video or RGB video screen, so to speak. So it's a character generator. It's got a built-in character generator ROM. It can generate 24 columns by 12 rows, not huge, and each character can be 12 by 18 dots. So there you go. That's rather it's rather an interesting way to do it. But we saw that in one of the cheap camera teardowns, I think, one of the more recent ones. So yeah, that's how they did it back then. They converted it into video, even though this camera doesn't have an external video output that can go off to a camera like your modern ones. They can go off to a monitor or a TV like your modern cameras do. And given that we have a CCD sensor input here, what's this analog devices part, the AD9800J? Well, of course, it's a CCD signal processor, and it's coupled into this part, another Hitachi part. I couldn't get any info on that, so I probably need to look harder, but that could be doing JPEG compression, for example, or something like that. It's a pretty big beast, so whether or not the JPEG compression's done in the main 32-bit processor, Hitachi processor we saw before, or in here, I mean, this is a big bit of silicon, I suspect. So yeah, I think there could be some beefy signal image processing type stuff going on in there. Curiously, there is an unpopulated connector there, which we can zoom in on. We will zoom in on just because we can. This camera can't focus all the way in at the moment, by the way, because this thing is too high. This camera is too thick and too high off the bench that it doesn't allow us to do full zoom on that. And this puppy down in here, the 88146A, I believe that's a Fujitsu 12-channel 8-bit DAC. So they're obviously using that for outputting some sort of, bias levels or something to that effect. I don't know precisely. Now, I was getting a bit concerned about the lack of custom Sony parts on here, so I took the screws out and let's flip it over, and ta-da, here we go. Now we're talking. This is what we expect to see in a Sony product, custom Sony parts. Now,
I've had a look for these numbers and I can't find them anywhere. So yeah, I mean CXD3125R, you can find lots of brokers that may or may not have stock of this sort of stuff. And of course we need something for our motor drive, so here's like a dead giveaway, all these big beefy tracks on here for the motor drive. This connector is our CCD data coming out into our CCD image processor here, but this connector obviously used to drive all of our motors, zoom and focus and all that jazz, and it must be that puppy there, that NEC controller there. It must be a motor drive controller, but what these parts are doing around here, I've got no idea. Now what is that, and why is that mounted on an angle? It's the only part on the board that's mounted on an angle. Interesting. I've got no first guess on that one. And it looks like we've got ourselves a Mitsumi floppy drive here. We've got some test connectors, test pads going on down in there. So there we go. That's for maybe the floppy drive alignment or something. Who knows? I don't know. Would have come aligned, surely. But they've gone to the effort to cut out the plastic in there. So I'm probably not going to take the rest of it apart, because the only thing we've got on the back side is just the display and the buttons, and well, I'm not, you know, that doesn't really gain us much info. I mean, we've already seen that the motor controller is on here, so really, you know, So I'm pretty darn happy with this Teardown microscope. Actually, it's, you know, it works really well. I've got my tilt swivel monitor up here, and I can direct view out of the microscope as well as capture it. I've just got my capture button here. I just hit that, and I've got my Samsung Go mic hooked up on top of here, and it all just records, and fantastic. Winner. A few more little touches. I need a DVI or HDMI switch box so I can switch between the monitor and the PC and stuff like that. But yeah, this is going to work really well for teardowns, and the quality, fantastic. So there you go. I hope you enjoyed that retro teardown. The Sony Mavica MVC-FD7, one of Sony's first practical digital cameras, and saved to floppy drive. It was fantastic back in its day. I love it. And well, that's what's inside it. The march of technology is just unbelievable. That's 17 years ago. That's 1997, really. And digital cameras proper didn't take off until, you know, 2000, like the early 2000s, really, before they started getting quite decent to replace your film camera with. So there you go. Hope you enjoyed it. As always, there will be high-res teardown photos at EEVblog.com. That'll be linked in down below. And also, if you want to discuss it, the best place to do it is the EEVblog forum. And links down below for that as well, as always. And if you liked the video, please give it a big thumbs up. Catch you next time.